Hello everyone. Today let's talk about Java concurrency and multi-threading. Well, since you all know that it has a lot of topics and we are not going to cover all the topics in one video, these are the table of content which I have created for the particular playlist, which and in parts. So we'll be talking about multi-threading and concurrency in 12 different parts. In our first day, we'll be talking about these particular stuff. So, what is a thread? What is the difference between multitasking versus multi-threading? What is the life cycle of a thread? So, basically, there are 5 different states wherein the thread goes. So, what are those? We'll talk about that. After that, we are gonna discuss how the thread creation works. Basically, what are the 2 steps via which we can create the thread. Post that, we'll be talking about different methods. So, what is the difference between thread start and thread run, which we should use and which we shouldn't? Then we're going to talk about the priority of a thread. Is it really important to set the priority of thread, or how much importance does it have? And lastly, we are going to talk about daemon threads. So these are basic stuff that we are going to cover in today's topic. Let's start then. So in our first day, as I discussed, so these are the basic points we are going to talk about. Starting with the first point, so what is basically multitasking and what is multi-threading? What is the difference between the two? Usually we all get confused whenever we are going to get asked that, okay, explain me multitasking and how does multi-threading is different from multitasking. So it's very basic. Okay, multitasking is nothing but basically one CPU or a computer is running multiple programs. If you all have noticed, if we are downloading a very big file of any movie or anything or any application, and at the same time we are playing game as well, the file is getting downloaded in the back, right? So basically our computer is doing multiple tasks at the same time, right? This is nothing but multitasking, as the name suggests. However, what is multi-threading? So in multi-threading, we have one CPU or computer, it's running multiple programs or process at this time, which has multiple threads of execution inside that particular process. So now when we talk about multiple threads of execution inside, you all must be talking or thinking about that, what is a thread, Vasudha? And how does but I can talk about process and thread later on as our second point. But before that, as we are talking about multitasking and multi-threading, why in today's world we are focusing so much about multi-threading, and how is it better than multitasking? So what do you think, why it's better to write a program with different or multiple threads? What it does is it's helpful in a way that it provides better CPU utilization. So what happens is thread at some point load data from the disk, right? And at that point of time, our CPU remains idle. So basically, we are wasting CPU cycle, right? And what we can do is we can utilize those CPU cycles in order to perform some other task at the same time. This is nothing but multi-threading. So when we talk how is it better, so we can say that it's better in CPU utilization. Also, it's better in IO utilization. Okay, so it's saving us CPU cycles in a nutshell. But at the same time, we have some multi-threading issues as well. What are those issues? So it's basically race condition. We are going to talk about it in detail. We have to solve the problem of deadlock. How can we cover up with that? Then we have something called as starvation. There is a concept of mixed signals as well. These are all basically mutable state currency and or the shared concurrency, the shared mutable issues that we are going to talk about. In addition to that, we have no shared mutable concurrency as well. And what happens is that is basically the functional parallelism and the separate state concurrency. So these are some of the basic issues that we come across when we are talking about multi-threading issues. We will elucidate about this in later point of time. However, let's go and start with the basic process. So like we talked earlier, or we discussed earlier, that whenever we are talking about multi-threading, it includes multiple threads of execution inside it. Okay, so what is a process and what is a thread? Basically, what happens is process is nothing but an instance of program. So whenever our program is getting executed, we have a process getting created at that point of time, which has its own resources, its own memory, threads. The operating system basically allocate resources to the process whenever it is getting created. And whenever at the compilation time, so whenever we are running a Java class and it's getting compiled using Java C my class name dot class, right? At that point of time, the JVM starts a new process and usually assign some memory to it. However, if we want to customize the memory, that hey, CPU, I want to use only this much of memory, and this can be the maximum memory, we can give this particular command. So basically, Java xms256m hyphen xmx 2G than our main class name. Now, what does this XMS256M and XMX2G mean? Basically, XMS256 mean it's the initial heap size that we are declaring, that okay, I want a memory of 256 heap size and the maximum. So XMX is basically the maximum heap size versus XMS is the initialization heap size that we are going to declare while assigning memory to our process. In addition to that, what is a thread? Well, basically, thread is a lightweight process, or you can say it's a smallest sequence, or yeah, sequence of instruction that is getting executed by CPU independently. So whenever we are executing the smallest set of instruction by the CPU, that is called as thread. So whenever we are talking about multi-threading, we are including multiple threads in order to provide parallelism in our particular task. Okay, so this is basically process versus thread. And when one process can contain multiple threads, and whenever a process is getting created, it starts with one thread, which is called as the main thread. And if we have to declare multiple threads, then we have to create a thread and execute task as per our convenience. Okay, so we'll see about it, how to create a thread, how to start a thread, and what are the different life cycle of thread. Starting with different life cycle of thread. So what do you think, what are the different steps in a thread, or different states of a thread? Let's see about that. So let's talk about all the steps. Okay, let me come here. And okay, so well, basically there are 5 types of threads. Okay, what are those threads? So whenever a thread is getting created, the first state that it is going to get declared is, oh wait, let me get black color. So the first step that is going to get created is the new state. Okay, so whenever we the thread is getting created, or we are doing thread initialization, at that point of time the thread is in new state. Post that, whenever we are starting the thread, the next stage of thread that it comes is runnable stage. So this is the second state of a thread. And after that, whenever we run a thread, it goes to running stage. Now what happens is, we don't have to specifically mention to run a thread whenever we are starting a thread in our program. And inside that itself, it's gonna go from runnable to running state. However, we'll see that what is the difference between start and run thread, and what should we use ideally, what is the issues with basically run method, we are going to talk about that later, okay? And after that, whenever at last the thread is getting stopped, or because of some unexpectation it is getting terminated, at that point of time, the last state that the thread goes through is terminated state. So this is the ideal flow. However, in between, there are certain other states that include in a thread life cycle. So what happens is, whenever there is any IO task getting executed, at that point of time our thread gets blocked. So one other thread that state that we have is blocked state. And whenever the IO process is done, we send the signal that okay, the lock has been released and the IO task is particularly completed. In addition to that, we have one more state which is called as waiting state. Now, how does this waiting stage get invoked? It's nothing but whenever we call a method called as wait, at that point of time, this particular waiting stage gets invoked. And whenever we have to release a thread from this waiting stage, at that point of time, we have to call another method called as notify. So whenever we want to make a thread in waiting stage and perform some other task at that point of, or there is any dependency at that point of time, we call the wait method. And whenever we want to release a particular thread from waiting state, we'll call the notify method. One other state that we have is basically timed waiting. Now there are two types of waiting. One is waiting where we are explicitly calling the wait method. There is another way where we are sending the thread in sleep cycle, and that's nothing but timed waiting. And at that point of time, suppose we have initialized a thread and said that, hey thread, can you sleep for 10 seconds? After 10 seconds, the thread will become active and further execute the other instructions that we have provided in our particular program. So this is the basic life cycle of a particular thread. And at any point of time, be the thread is running or in new state, if we call stop method at that point of time, the thread will get terminated. Okay, so this is basically a life cycle of thread. The thread comes to new state. Once we call start method, it goes into runnable state. If there is any IO task happening, we'll perform the blocked state. And once the IO task completed, it will go back to runnable state. If we are calling wait method, at that point of time, it goes back to waiting state. After the waiting process is done and we are calling notify state, it goes back to runnable state once again. And the timed waiting is particularly happens if we are calling thread.sleep, wherein we are telling the thread that, hey thread, can you go to sleep for 10 seconds, 15 seconds, or even for a minute? At that point of time, it is called as time thread. And like I mentioned, from any of the stage, because of expected or unexpected issues, the thread can get terminated because of stop method. Okay, so this is basically life cycle of a particular thread. Now the thread life cycle is completed. Let's go to our next point that we have is basically thread creation. Now a thread can get created by a two-step. One is by extending a particular thread, and the second one is by implementing the runnable interface. Okay, so let's talk more about it. So how does the thread creation works, and how does those two process works in whenever we are talking about extending a thread, it's basically a single inheritance, because in Java we can extend only one class. And what all steps are required in order to extend a thread? Basically, we'll create a class which will extend the thread class. Then we'll override the method to define the task to be executed by the thread, and finally we'll create an instance of that custom class which is overriding the run method, and call the thread.start method to initiate the thread. Okay, so let's go and implement that particular scenario. So let's say we have created one class called as my thread, which is extending a thread. Okay, and here what we have done is we are just printing that, okay, the new thread that we have created, what is the name of the thread? We want to get the name of the thread. And in our main class, we'll define an instance of the custom class that we have created called as main thread. We'll start the thread, and after that we'll just print that the main thread is there and what is the name of the main thread. Okay, so if we now run this particular command, we'll see that both when we are doing a start method, okay, when we are creating a new an instance or extending our thread, at that point of time when we are starting it, both our main thread and the new thread, it's the single thread, right? Why does that happen? Because we are starting the thread, and another thing is we are extending the class. At that point of time, only one thread is getting invoked, and its name is thread 0. Okay, let's do now run command. Since we are already here, what happens if instead of starting the thread we are directly calling run thread? Okay, let's start it. Now if you'll see, the new thread that we have created, its name is main because it's using the same main thread that we have. And the main thread that has been created is thread 0. Okay, so what happens here is it's not creating a new thread, rather it's invoking and working with the main thread itself. So that's the problem over here. What happens is if this, instead of this, we are creating new thread. I'll talk about this later. What happens is if we are creating one more thread and we are saying that, okay, t1 dot run, and then we'll call t2 dot run. At that point of time, we'll see that both of the thread is calling main method. However, this is not the expectation, right? We are executing a new thread. We want a new thread because we want to make the system concurrent or parallel. And if both the threads are calling main method or main thread itself, at that point of time, we are not achieving concurrency, right, or parallelism. So that's why we don't want to use run method and we'll rather go with the start method. Okay, so now you'll see that we have a new thread created. Let me just keep it like this for now. Okay. So this is basically extending our thread. Now talking about the second method, which is implementing a runnable interface. And this is basically the preferred method in all the industry. Why? Because this inheritance, it's an interface class, right? So when it comes to inheritance, we can implement multiple interface. At that point of time, we can actually create multiple runnable threads or multiple threads which can implement the runnable interface. Now, what are the steps to implement a runnable interface? Basically, the first one is implement the runnable interface in a class. Then the same thing how we are doing in the extending. So extending method. So the second step would be overriding the run method to define the thread logic. Then we have to create an instance of the runnable class. And finally, we'll pass the runnable object to a thread object and call the start method to initiate the thread. Okay, so both the methods are similar of extending and implementing. However, here we were extending the main thread class that we have in Java, and in implementing the runnable interface, it's not a class directly, it's a interface that we are using. So it's more flexible to customize the run method that we have. Okay, now let's go and write the implementation. So here, instead of extending the thread, we'll rather use implements runnable. Okay, so here we are implementing a runnable class, and it's similar. So we'll just write that, okay, in our run method, we are saying that new method is created and it's the name of the thread that we have. Now coming over here, what we have to do is, instead of this, we'll create a runnable object, and then afterwards we have to create, let me see, we'll have to create a new thread. Wait. And here we'll pass my thread. Okay, so we have created an instance of the runnable object that we have. Let's call this as runnable object only. Okay, and we'll pass this runnable object over here, and then we'll start it. Okay, and once this will start, we'll say that okay, now we are in the main method. The main method is created, or rather main method is finished. Okay, why it's not working? We have run this. Okay, this shouldn't be a problem. Oh, this is my thread, right? Okay. Oh, sorry, I'm so sorry. Basically, we have to do thread.start and not runnable. So now if you'll see, we have a new thread created, and at the same time the main thread is finished. Okay, so this is about the Runnable interface that we have. So use cases, basically it is used in the industry side, and this is of minimal usage, the extending of a thread class. Okay, now what's the next thing that we have? We have spoke about the process versus thread. We have talked about the thread lifecycle. We have also talked about creating threads, the two steps that we have: extending the thread, implementing runnable interface. Now let's talk about the methods which I spoke you, right? The start method versus the run method, and which is useful and which is not. So basically what I mentioned was when we are talking about the run method, at that point of time, both the times only main thread is getting created, right? However, when we are talking about the thread.start time, at that point of time, two threads are getting created, and that's why it's preferred to use a start, because we want to achieve parallelism or the multi-threading concept, and not we want to use all the threads, the main method itself. So that's why we'll be using thread.start in all of our videos rather than going with thread.run. Okay. Now the next thing is thread priorities. So what is thread priority? Basically, priority is nothing but an integer from 1 to 10. We will setting up the priority of our thread from 1 to 10, wherein the 10 being creation of thread of highest priority and 1 being the lowest. So whenever, even if we are setting the thread priority while creation, that okay, I want my thread to be of priority 10 and I want it off to be 1, it's not necessary, or it's not a specific rule or a strict rule that the thread will get executed in that particular order itself. So that's why it's not hard and fast wherein we are declaring the thread priorities. However, we can try to do that and see if the scheduler is taking advantage of it or not. Okay, so that's all about the thread priority. We can customize the priority of the thread as per our convenience. Okay, and after that we have daemon threads. We have something called as daemon thread. So what is daemon thread? What happens is basically whenever we are talking about a thread to be a daemon thread, at that point of time, the background thread or the low priority thread that runs on the JVM to provide the service. Those threads are called as user threads. And whenever those background threads, we want to do like some of the tasks like garbage collection, or we want to monitor other threads or perform any other background service, though if we want to have a task or a thread which perform all these tasks, we can set the particular thread as the daemon thread. Now, what is the property of daemon thread? What happens is whenever all the user threads get terminated, at that point of time the daemon thread will already get terminated. So it's nothing but whenever we initialize a new thread, at that point of time we'll just directly specify that, okay, if we have initialized a new thread called t1, at that point of time I'll just set that, okay, set daemon equals true. Okay, so whenever I am declaring that my thread to be set daemon equals to true, at that point of time it will go and check or perform all the tasks as per my functionality which I have defined in my run method. And whenever all the other threads or the user thread that we have created, once they got terminated, at that point of time this particular thread will also get terminated. So you have now covered up these particular properties, right? You know what does thread priority mean, how to start a thread, what is the difference between start and run, what is the daemon thread, how are we creating threads by extending a thread class or by implementing Runnable interface, and what is the life cycle of thread. Basically, we have drawn this entire diagram to understand different life cycle of a particular thread, and what is process versus thread, and what is multitasking versus multi-threading. So that's all about this video. I guess it's been some time now, and we'll talk about the later concepts. So basically in our next session we are going to talk about the thread synchronization. So what does the shared resources and thread interface mean, the synchronized blocks, reintrant logs, volatile keyword, what are the atomic variables, thread safe collections, etc. Okay, let's talk about these in our next video. That's all from my side. Bye bye.